You're standing on a platform and a modern subway train glides in. It stops right on the mark. The doors slide open, perfectly aligned with the platform gates, and you step aboard without a second thought. It feels completely effortless. Behind that smooth arrival is a volatile intersection of dozens of engineering disciplines, all forced to function in unison. The core challenge of building these networks is the silo effect. Civil engineers design concrete tunnels, electrical engineers map high-voltage grids, and developers write automated driving code. For a large portion of a project's lifespan, these teams are designing highly complex components in total isolation. Eventually, those isolated blueprints have to become physical reality. When they aren't synchronized, the automated software fails to talk to the physical brakes, or the multi-million-dollar train cars simply don't fit the platform dimensions. Without a central authority dictating how these pieces fit together, a multi-billion-dollar transit project quickly collapses into dysfunction. You need someone whose sole purpose is to force all of these isolated disciplines to speak the exact same technical language. That central authority is known as a railway systems interface and integration engineer. It's a highly specialized role designed to unify multidisciplinary chaos, and it is exactly what lovely Paralan Mabitazen does. To do this effectively requires a specific toolkit. Lovely built hers by earning a Bachelor of Science in Railway Engineering and Management, and then pairing it with a Master of Science in Construction Management. That exact educational combination allows her to evaluate a transit project from two totally different altitudes. She can assess the macro-level logistics of pouring thousands of tons of concrete, while simultaneously tracking the micro-level behavior of delicate system operations. Her work on international megaprojects, like the Dubai Metro Blue Line, begins long before the first shovel hits the dirt. This initial phase is called requirements management. During this stage, she takes the massive scope of the project and sets strict technical parameters. She has to align disparate teams of global contractors, ensuring everyone agrees on exactly how their specific parts will eventually connect. By catching misalignments at the blueprint stage, she prevents catastrophic multi-million-dollar physical clashes from happening later on the construction site. But eventually, the blueprints turn into raw construction. Building new rail networks within the ultra-dense, historically gridlocked cities of the Philippines presents a logistical nightmare. This is where interface management comes in. It is the active, daily process of identifying real-time technical conflicts between the international engineering teams and the existing local infrastructure, and solving them before they halt progress. Resolving these conflicts requires intense stakeholder collaboration. You have specialized contractors, local government officials, and international partners, all with entirely different priorities. Keeping a project moving means constantly aligning these competing interests. One of the most delicate challenges in this phase is rolling stock integration. This is the exact moment when the newly manufactured physical trains are placed onto the freshly laid tracks, and ensuring they interact flawlessly with the local power grids and automated software. It is this rigorous risk management and tight technical coordination through the chaotic construction phase that transforms a pile of potential engineering disasters into a unified, functioning transit network. The final hurdle is the commissioning phase, the absolute testing ground before opening up major transit systems like the MRT-7 and the North-South commuter rail to the public. Systems integration is most effective when its immense multidisciplinary effort remains invisible to the passenger. Success at launch is measured by rigid, uncompromising metrics. It requires unbroken technical excellence, strict regulatory compliance, and a demonstrably safe passenger environment. If those aren't met, the trains do not run. Beyond the technical schematics and safety audits, this work is driven by a passion for engineering innovation and pushing for sustainable transportation models in growing urban centers. By mastering the hidden interfaces of these projects, lovely Paralan Mabitazen delivers the infrastructure that moves entire populations and strengthens the communities they serve.